All right, guys, we're going to get into iris now. If they ask about pigment dispersion syndrome, you guys know that it's going to affect the back layer of the iris. You know that's the posterior pigment epithelium. You know that's because the zonules are kind of scraping against that, right? If I asked you, though, like uveitis, what layer of the iris would uveitis affect? That gets a little bit more challenging, right? Because you might remember that uveitis is a breakdown of the blood-aqueous barrier, right? Yeah? So we're going to get into where are there blood vessels at in the iris, okay? If I talked about Fuchs heterochromic iritis, if I talked about that condition, where would that affect it? You guys know in Fuchs you get heterochromia, right? Which is a change in iris color. And the big thing you're going to learn there is that inflammation in Fuchs is going to strip away melanin, okay? And melanin is what gives us our iris color, right? So if I obviously have blue eyes, if let's say you had brown eyes and you're watching this, we both have the same number of melanocytes, but we have the different amount of melanin. You have more melanin than me, right? If you had a disease process like Fuchs that was stripping away melanin, your eyes would become more blue, okay? And that's a big picture point I want you to know is that in Fuchs, you're going to always shift towards a blue direction with your eyes. If your eyes are blue right now, it's going to become more blue. If they're brown, they're going to shift in the blue spectrum. That's a good test question. We'll talk more about that now. So let's map out the iris. There's 4 layers. Let's get at it right now. So guys, I just mentioned how the iris color depends on the amount of melanin within the front layer of the iris, which is the anterior border layer, right? Well, sometimes people confuse melanin, melanocytes, melanosomes. So I want to give you just a quick sketch of that. This will be really fast. But 1 out of every 10 cells in your body is a melanocyte. So obviously really common. Okay, so that's your melanocyte. Inside a melanocyte, you're obviously going to have melanosomes, which is an organelle. Okay, and those melanosomes are going to produce the melanin. Okay, so remember we talked about how on the test, if they ask what determines what your iris color is, it's the amount of melanin right here within a melanosome, right, within a melanocyte. Okay. And you're going to see in the notes, it's primarily the amount of melanin within the anterior border layer that determines iris color, but a little bit the stroma as well if they give you a pick 2 type question. Remember, all of us have the same amount of melanocytes, okay? So don't pick that on boards. You're going to see that as you get into disease. A lot of the cancers, though, have to do with this. It's a problem with melanocytes that leads to cancer. But when it comes to iris color, pick melanin. Let's take a fresh look at this. I want to talk about the layers of the iris. Remember, there's 4 layers, right? And so I'm going to draw this slowly because I want to nitpick a few details that could show up on the test. The iris root right there is in the corner. It's the thinnest area of the iris. You know there's a hump here called the collarette, thickest area of the iris. That's the collarette. And we extend down here like this. Okay, that's the back layer of the iris. The back layer, what's that called again? The posterior pigmented epithelium. I don't know why, okay, but the pigment epithelium becomes the non-pigmented right here of the ciliary body, we'll talk about that in a minute, which becomes the sensory retina. So on the embryology chapter, you'll see that knowing the back layer of the iris, okay, which is again the pigmented epithelium, okay, knowing that that back layer becomes, okay, the non-pigmented right here, which becomes the sensory retina, also called the neural retina, right? Those 3 are forever linked in your mind. You want to link those rock solid in your mind. Now let's go after each one of these layers. Again, this front layer is going to be called the anterior border layer, okay? Again, all about melanin there, right? That's the collarette that we're looking at here. So again, all of this is anterior border layer, right? So I'm going to put a C there for collarette to remind you. Now right underneath that anterior border layer, the next layer is obviously going to be the stroma. Stroma is where you always have blood vessels. For example, if they say something about a patient wearing their contact lenses too long and they have neovascularization of the cornea and they ask you what layer that neovascularization is located, you're going to say the stroma. Don't pick epithelium on boards. Likewise, if they ask you in the choroid, where are the SPCAs and LPCAs, you're going to say the stroma. Think blood vessels when we think stroma, okay? Right underneath that collarette, you're going to have the minor circle of the iris. So I'm going to put a little small circle there in the stroma, the minor circle, and that is going to be non-fenestrated, meaning we don't want that to leak, okay? So if they ask you about uveitis and what does it break down, it's going to break down that minor circle right there, okay? If they ask you in particular in the iris, it's breaking down the tight junctions. So when you think about that minor circle, you want to think about tight junctions right there, okay, making it non-fenestrated. I know you guys love fenestrated, non-fenestrated. That's sarcasm. A lot of people hate that stuff, right? But when we get down here to MACI, the major arterial circle of the iris, MACI is fenestrated. okay? So MACI has gaps in it. Remember, we need the ACAs, which combines with the LPCAs, for the fluid to leak out and sit there and then be chosen to get across, right? And remember, beta 2 receptors push that sodium and bicarb across with water following, creating our aqueous humor, okay? So again, we have the front layer, anterior border layer. Next layer, we have the stroma. And what's in the stroma? The minor circle. We also have the sphincter muscle right there. And I'm putting these in the exact location. So if they ask you, the sphincter muscle is going to be near the edge of the pupillary margin. Okay, behind the stroma is going to be the anterior epithelium, behind that layer. So again, there's 4 layers. Last but not least, the pigmented epithelium. Is there anything in the anterior epithelium you should know? And I would say yes, it's the dilator, okay? And we'll talk about that in just a second. I'm gonna draw you a little sketch. Last but not least is the pigmented epithelium. I would want you to know that this back layer of the iris, the pigmented epithelium, is where you get pigment dispersion syndrome, but it also curls up like this and forms right here, the pupillary ruff, or you guys may know that as the pupillary frill, okay? I want to take a fresh look at this, and I want to show you just in more detail how to think about the collarette, okay? Because sometimes people look at the collarette and it's kind of confusing. That's someone's pupil. If you looked at a picture right now, you'd see the pupil like just a random person, like a picture, a photo you take of a friend of yours. You're going to have the pupil in the middle, and right outside the pupil is going to be the collarette, which kind of looks like this. I know you guys have seen that before, right? And you guys know the collarette, again, is the thickest area of the iris. So if you looked at this from the side angle, the collarette would be sticking out a little bit. And what I would know is that anterior, let me say this way, interior to the collarette. So in this area right here, you're going to have the sphincter muscle. Okay, remember I showed you that in that other sketch, kind of how to think about that. But it is a circular muscle. You've heard that a million times. The sphincter is circular, right? And it runs right in this region, okay? And they might want you to know, what is the name of this region inside the collarette, interior? And that's called the pupillary zone. I mean, not rocket science, but a picky test question could be wanting you to know that the sphincter is in the pupillary zone, okay? And anything out here, so if we had to finish our drawing of the iris like this, okay? Anything outside of this zone right over here, this is called the ciliary zone, okay? Ciliary zone. And they might want you to understand, for example, that the dilator muscle, all right, is radial. You've heard that phrase before. It runs like this, like spokes on a wheel, okay? And so if they ask you on boards, the radial or the dilator muscle, right, is in both zones. It's in the ciliary and the pupillary zone, whereas the sphincter is only in the pupillary zone, okay? One other point I want to make about this, okay, so we're going to call this the dilator, okay, also the radial muscle. Remember, and hopefully you can tell now as you look at that picture why it's obviously called radial, okay? That dilator muscle right there has alpha 1 receptors, okay, alpha 1. Say that to yourself over and over because you're going to see that when we get into pharmacology. You're going to want to know that, okay? The sphincter muscle, I don't think this muscle right here is not near as important as knowing the exact receptor, but I would know, and you'll get to pharmacology and see this, it has M3 receptors. That's kind of a good thing to remember about that. This one is a very testable concept, okay? I would know that because phenylephrine, for example, is an alpha 1 agonist. That's why it's used to dilate the eye. All right, guys, so as you look at that, again, 4 main layers, right? Anterior border layer in the front, iris color, right? Next one, stroma. You're thinking all about that's going to be where blood vessels are located. The non-fenestrated, right, of the ciliary, of the iris are going to be there, right? So you're thinking blood aqueous barrier. When you think about blood aqueous barrier, by the way, I want you to know that blood aqueous barrier consists of tight junctions in 3 places. We're going to get into that in physiology, but these are 3 places you don't want to have leakage, right? And one of those is the iris, because if blood leaks out of those blood vessels in the minor circle, it's going to cause that iris to swell. And when the iris swells, now the iris is in closer proximity, right? If this is the iris and this is the angle, this is the iris right here. If the iris starts swelling, now it's going to be in closer proximity to the trabecular meshwork and can cause peripheral anterior synechia, right? Or if the iris extends posterior like this, now the back of the iris can start to extend into the lens, right, and cause what? Posterior synechia, right? Isn't that cool? So when you think about that anatomy, I think that's really cool, by the way. I know I'm kind of a dork, but when you think about that, you want to think we do not want leakage in the iris, okay? And that's a big deal. Again, that's called the blood aqueous barrier. When I say those words, blood aqueous barrier, I want you to think it's a barrier to keep blood, right, out of the aqueous. I know that sounds like a smart aleck, but that's how you want to process it. And you want to think to yourself, blood aqueous barrier is tight junctions in 3 places. 3. Okay, you'll see that again later on. So again, that's all about the minor circle, non-fenestrated. Major circle, fenestrated. We want it to be fenestrated, right? We need fluid to leak out, but then there's a blockade there. What is that called? The blood aqueous barrier. So where's the second location of the blood aqueous barrier? Right there on the non-pigmented epithelium, right? Because the fluid sits there, it wants to cross, but it can't unless it's one of the 2 Chosen ones. What are the chosen ones? Sodium and bicarb. Yes. How does it get across? Beta 2 receptor, right? Now, another question on that. What is that process called of pushing that sodium and bicarb across? Active secretion. Great. Quick farm tie-in real fast. You ready for this? This is awesome stuff. Name a farm drug that's a beta blocker, okay, that's your least efficacious beta blocker. Okay, what comes to mind? Least efficacious. Well, in other words, it's kind of worthless, like you're never going to prescribe this drug. But the one you want to have that comes to mind is betaxolol, right? And betaxolol is worthless because it stops beta 1 receptors. Well, we don't have hardly any beta 1 receptors there. It's mainly beta 2, okay? So that's kind of a cool tie-in as we get into pharmacology, is to picture that beta 2 receptor there. It'll help you with pharm as well. Third layer after that we want to talk about is the anterior epithelium. That's where the dilator is located, right? The dilator is in how many zones? 2 zones. What are they? Pupillary and ciliary. While we're at it, what was the sphincter muscle again in? How many zones? 1 zone. What is it? Pupillary zone. It's a circular muscle, right? What's the receptor on the sphincter? M3. What's the receptor on the dilator? Alpha 1. Good. Last but not least, pigmented epithelium in the back, right? The pigmented becomes what of the ciliary body? It becomes the non-pigmented of the ciliary body, right? Right. By the way, when you picture that right there, the non-pigmented, what's the region of the ciliary body called right there? If you don't remember, don't worry. We're going to hit it on the next video. That's the pars plicata. So guys, you're ready. Hopefully that feels good. You're nailing these sections one by one. Go ahead and take a quiz, see what you got, dominate another section, and we'll get into ciliary body next.